Good morning, everyone. Welcome to the session on PIDs. Before the recording is starting, we have some housekeeping stuff here. So someone lost a bag yesterday at the dinner, or if I understood correctly, someone took the bag of someone else's. So if you are missing a bag from yesterday evening, the bag is now at the reception and you can take your bag. This is the first thing. The second thing is for the online participants. If you are with us during the session and if you have questions during the session, please feel free to mention this in the chat. We have someone who monitors the chat and you will be able to put your question on the screen, or you will be able to ask us directly via the screen. Yeah, it's always a challenge to be the first session on the day after the conference dinner. So we are very happy to welcome you here at the session. I'm also happy to see some great dancers in the room from yesterday evening. Our session is about PIDs, persistent identifiers. Together with Temis, we will chair the session. I think this is probably the agenda for today. I'm a bit surprised with this one. Our breakout session is in the middle one, in the room Barcelona. We have strong competitors in the two other rooms. Also, that's why I'm quite happy to have you here in this room. We have four speakers in this session. After a very brief welcome, two of the EOSC projects will present the results, and the PID task force of EOSC will say some words about the results and what happened during this time. I'm surprised with this again. So this is not our slide deck. It would be much easier if we could make our presentations with our own slides. So if you... In the meantime, I'm starting without slides. So the session goal is to discuss issues around and about persistent identifiers, because PIDs are one of the great implementation challenges of EOSC. And we try to understand in this session where do we stand now, and whether the projects, whether the PID task force, and whether the actors of the PID landscape addressed those challenges right, and whether these actors addressed the right challenges. Basically, this session, will present the achievements of the PID task force of EOSC, and among others, two projects, the FairCore for EOSC project and the RACE project. We reflect on what still has to be addressed and what have been achieved. Yeah, basically we will start with the PID, we will have an introductory session just to understand what belongs to the PID landscape in the EOSC context and what is the implementation challenge around PIDs in EOSC. Then Temis will say some words about the task force, what the task force is doing, how the work of the task force is organized and structured, and what is expected to be kind of outcomes of this task force when the mandate ends at the end of this year. Then we will continue with Tommy. Tommy is the project coordinator of FAIRCORE for EOSC. FAIRCORE for EOSC is in this session because FAIRCORE addresses some of the implementation challenges defined in the SRIA, in the Strategic Research and Innovation Agenda of EOSC. And Tommy will present some of the new services developed in this project and might be of interest of the PID community. Then Gorka will finish the row of presentations presenting the RAISE project. RAISE is in this session because RAISE introduces a new PID type, the research analysis IDs. I'm very interested to hear more about this new PID type. He will also speak about the technology behind RAISE is using for the PIDs. I'm also interested to learn how blockchain is used in this context. And basically, Gorka will say also some words about how they support controlled and protected data sets in the context of personal and sensible information in the health domain. Starting with the first presentation, just to set the stage for the other presentations, I would briefly mention that okay, thank you. I would just mention that when we talk about persistent identifiers, probably everybody thinks about different things because the community is so huge in the EOS context, and the landscape is so diverse, and also there are quite some documents around which describes persistent identifiers in the community and in EOSC. Yeah, thank you. Basically, there are quite some established services out there in the EOSC community. There are well-known and established PID providers like DataCite, like Crossref, like the Persistent Identifier Consortium, which provide different kind of persistent identifiers for different purposes. And they are a kind of a trusted PID ecosystem, or they have become a kind of a trusted PID ecosystem, and provide a kind of a new generation of PID services. These kind of scalable identifier systems support the researchers, supports the different science clusters, and try to capture different phases of the research activities across the entire research life cycle. There are quite some challenges here. There are siloed services which are not necessarily interoperable with each other. There are important types of object which are not adequately covered in this PID ecosystem. Some of the processes around are still remain manual, and the adaptation, there is adaptation, but this is not consistent across all disciplines. So we pictured three of the main documents in this context. One of them is the SRIA, the Strategic Research and Innovation Agenda of EOSC. Another one is the PID policy, and the third one is a PID architecture. These are kind of basic introductory points to the PID landscape in EOSC. Some of them are being updated regularly, others probably not. And coming to the next one, I would just to mention that the SRIA, for example, mentions 3 different areas relating primarily to technology challenges and how to implement the EOS ecosystem. Some of these areas are really concrete when it comes to PIDs. They say something about the identifiers, like how to identify new resource identifier types or how to implement the EOSC PID policy. And other areas are less concrete when it comes to, for example, metadata or ontologies. So if you were asked which type of persistent identifiers you have in mind, then probably most of you would think about identifiers around people and researchers, just to name ORCID here. But also nowadays organizations, institutions, places are identified with IDs, just to name ROR, the Research Organization Registry in the EOS context, or GRID, the Global Research Identifier Database. But also things, any kind of things are identified in the EOS context, depending on the research discipline. Probably the most common thing is that research outcomes, research outputs are identified. Scientific publications, the most common use case. But nowadays also reviews, preprints, or projects get persistent identifiers. Also, research inputs are being identified. So, like grants, or funders, or even projects, or scientific institutes, instruments which were used to create data sets are also becoming identified by persistent identifiers. And there are, of course, other things which are needed for the research, like samples, or research activity IDs, or research analysis IDs are used nowadays. So there are quite some type of PIDs exist around there. On the figure, the overall idea is to somehow connect these kind of IDs with each other. So link those objects related to research together, and to show the connections between the variety of PIDs. For example, the most common use case probably, if you have a scientific publication, a kind of a list of authors get ORCIDs registered, or they have ORCIDs already, and the authors are identified with PIDs. The next step is the connection, to create this kind of connection between data sets which were used for the scientific results, and identify these kind of data sets with PIDs, and put these kind of PIDs into the metadata of the scientific paper, the scientific publication. Some of the projects and some of the initiatives in the EOSC landscape address the challenge to expand the PID graph, expand that kind of graphs, and include additional nodes of identifiers for the related outputs and resources, just to name the instrument identifier, which is more commonly will be added to the metadata, PID metadata of data sets. So we have quite some identifiers there. The challenge is how to resolve that kind of identifiers, what to do with that kind of identifiers. There are many PID systems out there, and especially the SRIA and the PID policy are mentioning explicitly that there should be a one-stop shop to resolve that kind of PIDs. So you don't need to train all of your systems to understand the different kind of PIDs, but at least the resolution of the PIDs should be able to made by a kind of a one-stop shop for PIDs. That's why we also have happy to have Tommy here, who will present a solution coming from the FAIRcore for EOSC project. Almost the last slide. When PIDs should be used? So when should be PIDs used? I think there are a lot of scientific publication how to define the research life cycle and what the research life cycle is. But the main message here is that ideally, the ideal policy would be to use always PIDs in any kind of the research life cycle. These might be different kind of PIDs. These might be different kind of policies, depending on the life cycle, depending on the policy. But it would be very useful to go with PIDs everywhere. And the final slide from my point of view, just to say that there are some help out there, especially because the EOSC community is becoming bigger and bigger, so you are not alone. There are organizations out there which probably have a generic or high-level focus, more high-level focus. I would just mention the international data organizations and probably our task force in EOSC, the PID task force, which has a dedicated focus on persistent identifiers. When it comes to projects, they usually have a more concrete focus, so they try to address well-defined challenges, and they do this with some funds, so they have resources to address that kind of challenges and deliver solutions. But probably at home, you might have some national consortia around persistent identifiers, might be a kind of a source for further information how to deal with PIDs. Probably you have a PID policies, a national PID policy, or national research data management policy, which says something about how to deal with PIDs. And of course, the community is always there. And probably in the EOSC context, there might be different smaller communities around PIDs, and the big, huge PID community still does not exist. The first two, so we have examples for the first two here. The PID task force will present itself, and the two projects will present itself. With that, I will close this presentation, and
I will continue for a presentation about the task force. I'm Themi Zamani, I'm from GRNet, and I am co-chair with Tibor at the task force. Sorry, I'm not used to using. The task force started with 23 members from various organizations. There were 12 from service provider organizations, 1 from research funding organization, 9 from research performing organization, and 1 person from a research community. We actually have a balanced group of PID users, PID experts, PID domain experts, and providers. Currently, some of them are not available anymore, and they don't participate in the task force, but in general, we have a good number of participants. In our task force, we use specific documents. We use the EOSC PID policy, the EOSC PID architecture document, and we started with a task force charter, and we updated it this summer. Also, we focus on the SRIA document and the MART document. We also have a space in the EOSC forum service, where you can find information about the task force and the work we're doing. We have to say that the mandate of the task force will end at the end of this year. So it may be, if you want to participate, it may be a new call so that you can participate in our task force. The main goals and activities and core activities of our task force is to provide input based on identified gaps in the PID ecosystem based on the SRIA and the MARS document, to monitor and provide community feedback of the implementation of the PID policy and the PID architecture, and to make recommendation to the EC via the EOSC Association for the integration of new PID services in the PID ecosystem. What we actually do is monitor and collaboration with other relative initiatives. Our main activities is to identify and describe emerging and standardized identifiers for resource types that are not yet standardized or used in, let's say, like the others, like the PID types that we know. It's the global PID resolution, which is actually the meta-resolver like the one that Tibor presented earlier. And these are services that can deal with multiple and different persistent identifiers. We're trying to review efforts to develop definitions for the most common data formats or building blocks of the PID ecosystem. And of course, we are trying to monitor, review, and comment on, we want to do that, on the EOSC PID, on the implementation of the EOSC PID graph. We're trying to find criteria against which a PID will be certified, and new tools will appear so that the PID infrastructure can get a certification based on the EOSC PID policy. And last but not least, it's that we're trying to gather best practices and PID use cases from various projects and initiatives so as to exemplify the fair data management and to inform communities about how to use the PIDs. It doesn't work. Okay. Our collaborations, external collaborations. When we're referring to external collaboration, we are referring to PID-related projects, communities, and providers, technology, and domain experts. Currently, we work close enough with the two main PID projects, like the FAIR Core for EOSC and the FAIR Impact, but we also have we are in touch with other projects, like the EOSC Cancer, the EOSC Focus, the Skill for EOSC, and the EOSC FAIRs, which are projects that some of our members are participating. Apart from this, we are also collaborating with other task forces. Mainly with these, we interact with these that have to do with data, metadata, data lifecycle, and data quality. Some of them are the FAIR metrics and data quality, the semantic interoperability task force, the technical interoperability of data and services, the long-term data preservation, and the rules of participation. We haven't started working with all of them, but we are in touch with some of these task forces. About the work that we have done until now and how we're working. In our task force, we have focus groups. When we are referring to focus group, we understand that we mean a team of persons that work for focus on a specific topic. The first group that was created was the mapping the current PID-related activities. When we started, we thought that the first thing that we have to do is to collect all the different things that we can find about PIDs. So what we did, we collected all the different PID types that have to do mainly with EOSC, the PID-related projects, and of course the providers and the services that have to do with persistent identifiers. This is not a finalized document, it is a live document because we add information whenever we have new. The second group is the group collecting community-specific use cases and perspectives on the EOSC PID architecture and the EOSC PID policy. And what the team did is to create a survey to collect the priorities for addressing gaps as well as use cases from different domains and different stakeholders. We validated the results, we created a report, and this will be published in the next few months, right? Our third focus group, it's a new one, it's the harmonization of the PID-related vocabularies. What we said is that now there's a lack of clearly defined vocabularies covering all the PID-related ecosystem, and this is why we started the group. What we want to do is to identify the work that is already done, so we're collecting all the vocabularies that are created in different initiatives or projects. So we have a base for the vocabularies that are currently used. Then we want to analyze the vocabularies that are really needed, because some of them are duplicates, some of them are big ones, some of them are small ones, and some of them has nothing to do with the PIDs. The third step is to try and identify the owner of these vocabularies in EOSC. Okay, someone created the vocabularies, but who can manage? Who is ready to curate this vocabulary so that they are always up to date? Identify who will be the hosting body, the last goal, and the governance body of these vocabularies in EOSC, so that they can be used by all related projects and services. Our expected outputs are, of course, a landscape analysis of who needs these vocabularies and why we need these vocabularies. The actual vocabularies, if they are big ones or simple ones per specific topics, or they're going to be linked vocabularies. And, of course, to update the PID policy with the vocabulary so as to be consistent with the work done. The last focus group is the PID policy in examples. One of the main questions that all our users has, not all of them, but the users that are starting reading the PID policy, is where can I find examples on how to implement what you're writing in the PID policy in my sector. So what we started is to try, so that's why we started this focus group, and wants to make examples of how to validate the PID policy as an actor in your sector. The expected outputs are examples that will be written and collected to make something pragmatic, high level, on top of the complex PID policy that they are reading right now. And the other thing is to collect examples from different areas and domains so as to share it with all other communities. That's all from the task force. Tommy now will say a few words about the FAIR Core for EOSC project.
Thank you. I'll come here so I don't block the screen.
I will go there.
Okay, thanks. All right, hi. So we have tried to pick out from the project those things that most correlate with the PID topic. We are, it's not my slide, but okay. Here we go. So yeah, we're a 3-year project, research and innovation action, which means we're doing concrete service development work. And we're roughly halfway through, and at our halfway point, we will release the beta versions of the components that we're working on to start actually exposing them to people to try them out a little bit. I have 5 minutes, so I have to be very efficient with these slides. So we have 4 topics that we mainly address, and these are things that SRIA has highlighted as challenges or gaps in the state of the art. And identifiers and interoperability essentially are 2 of the main things, with the kind of research software as an additional topic coming from this SIRS report, which was integrated in the SRIA. So yeah, all in all, we're developing 9 components, and I realized that I picked almost all of them for which are PID relevant, so I have a little bit more on 7 of them. I think I'm not very good at picking, I think. The PID meta resolver is essentially a system that tries to be like a hub or a top layer that would resolve all PIDs from different PID systems. And it would actually enable you to not just resolve the PID, but you could, we're working on kernel information for the PIDs. So that is essentially metadata for the PID that describes something about the object to which the PID resolves to. So you could actually query metadata on the PID without actually resolving to the document itself or the object itself. So this would allow you to resolve it to a landing page, get metadata on the object behind the PID or then result to the resource itself. Then a brand new PID system has been developed by ARDC, so the Australian Research Data Council, and that's the Research Activity Identifier. Now, ARDC has developed this in Australia, and we are now basically deploying and customizing this for the European context. What is a research activity in this context? It's not exactly a project. One of the developers is an archaeologist, and he always pointed out that it's like an archaeological excavation that goes on in the pyramids of Giza for 20, 30 years. You have a lot of people working on it, you make a lot of papers on it, and there's a lot of funding grants that go into it. Many different projects can be actually incorporated in this broader activity. And this essentially is an envelope that tells about all of the things that are related to this activity using PIDs. So it points to the grant IDs, it points to the orchids of the researchers, to the DOIs of the papers, and it's actually a way that you can collect metadata or the PID graph information, how the different PIDs are connected or the research objects are connected to each other. So it is not just a PID, but a mechanism of producing this graph data. Yeah. I have interesting reveals in this. I did, of course, looked at this from my computer, and I didn't realize I have these cool animations that I had no idea about. Then we have the research software APIs and connectors. So software heritage is collecting research source code as a kind of a internet wayback machine. This is a source code wayback machine. So it archives all of the research source code that it can get its hands on. And it is introducing the software heritage ID, which is, I'm not sure if it's like a hash, but it's essentially calculated from the source code to be a unique identifier for a particular set of source code that you have used, for example, in a paper to carry out your analysis. So it's kind of citable in that sense, and identifies the exact source code instance or variant that was used in a particular analysis. Now, software is a complex digital artifact with many different levels of granularity, and researchers, when you are kind of making a publication, you have to be able to point exactly to the source code that you used in your analysis. So this is came out as a recommendation from this EOSC SIRS report, and they are in the process of starting the ISO standardization of this identifier. And then we have the EOSC PID Policy Compliance Assessment Toolkit. So this is a concrete service that is being conceptualized by DANS and implemented by GRNet. So if you have questions, ask Themis. And Wim, yes. So this is essentially a service. If you know that, like, you have maybe seen this FAIR assessment. The FAIR has the F, for example, FAIR 1, FAIR 2, FAIR 3. So they have criteria that breaks down what is findability, for example. And then each of those different sub-criteria for findability is assessed. This is basically a similar thing for the PID policy compliance assessment. So they are quantifying or breaking down the EOSC PID policy for different aspects that can be measured like services can be measured against. So whether it's compliant to the EOSC PID policy is different criteria. And then the EOSC PID graph. So this is a lot about the connections, so the information on the relationships between different research objects. And what we do in our project to this existing PID graph is actually we are collecting much more of this connection information between the objects. We know quite well the research objects themselves, the publications and the researchers, but we still need more information on the connections between data sets and papers or projects and data sets and so forth and so on, and research infrastructures. But then besides actually collecting more of this graph data, we are also trying to bring into this graph new research objects that have started getting PIDs, such as the instruments or data management plans. Then this is not directly PID anymore itself, but new things that we're PIDing. So the EOSC metadata schema and crosswalk registry is a service where you can deposit metadata schemas, and then you can actually deposit crosswalks, but you can also visually actually create crosswalks between different metadata schemas. And in this context, we are going to PID the schemas, the schema elements, and the crosswalks. So a crosswalk can be versioned, it can have provenance, and each of these different variants of the crosswalks will be PIDed, so that we can identify what was used to convert data between different services. And finally, the data type registry is a service that actually supports the PID meta resolver by having a place where these kernel information profiles, data types, so that's the metadata on the PIDs, can be actually described. It supports the metadata schema and crosswalk registry in actually giving PIDs for the data types that are used to describe the metadata. So these are essentially PIDed data types. And I probably overused my 5 minutes, so and that's about it. Thank you.
Okay, I think I will move to this one directly. Good morning, everyone. I'm Gorka Pelde. I'm a principal researcher from Vicontech, which is a research center in northern Spain, located in San Sebastian. And I'm coming today as a representative of the RACE, EOSC RACE project. I'm the technical coordinator. Okay, so RACE, it's a EOSC project, which it's entitled as a Research Analysis Identifier System. And the main aims of the RACE project are to provide mechanisms for distributed crowdsources data processing system, moving from open data to open data open for processing. So the idea is also to be able to handle protected and controlled data sets, not only. And it's also aiming to accredit the work and the research data that it's made accessible by different researchers. The motivation for RAID also comes for the current obstacles to the management and sharing of research data. This is overall different reports coming from the European Commission report. And more focusing on the need of a RAID, I have underlined these few points, which are commercial use, misinterpretation, falsification of risk, lack of recognition, and data protection, in the sense of that both RACE technology tries to allow for identifying and recognizing the work of the people, and to be able to reproduce the work done. Okay, the motivation for the RAID, or the Research Analysis Identifier, comes from the gaps from this RIA on PIDs and sensitive data and new technologies. And also it's reflected on the priority to develop a standardized identifier for new resource types that have not been identified yet or defined, standardized yet. So the identified gap is in having reproducible software experiment persistent identifiers supporting protected and controlled data sets. Okay, so what's the proposed concepts or the concept that we are implementing? So the Research Analysis Identifier ID aims to guarantee the reproducibility of software analysis reflecting the authorship, source dataset, can be both open or controlled datasets, algorithm, and results. So the forcing benefits of this PID are to allow researcher, journal, or patent reviewer or a company, when they are purchasing an IPR or want to reproduce the experiment, so they are able to have the certainty and guarantee that the experiment was done with by somebody specific, which with a specific source code, with a specific data set. It's the concept, and when it was done. I'm looking at the timestamp. So it's maybe reflected that he was the first one doing this experiment. And as we were focusing also on the acknowledgement, this PID, and we aim to track the shared protected, non-protected data set, and also the script usage to acknowledge those that are contributing to overall availability. The implementation goes that once data sets are uploaded, currently we are providing them internal PIDs, and they are hosted in trusted lab or RAIN nodes. Similar for scripts, and upon a successful experiment run that script code goes against a given dataset, the registration process is request is composed. So there is a specific hashing strategy in steps that is applied, and this final hash is written into the blockchain. We have different implementations, one with BigchainDB and Hyperledger Fabric, and different services in the race system to enable to resolve them, which is composed by different internal PIDs, which allow for reproducing the experiment being done. Okay. We have a certain ecosystem or use case approach in order to work with the RAID in the center, which is making datasets accessible, finding different datasets, preparing processing script on synthetic or different anonymized dataset that might be provided to the external researchers, uploading the processing script, if the results are successful or the run is successful, registering this with a RAID, being able to publish these results by the researcher openly in different OpenAir graph or other areas, allow the researcher journal reviewers or so to validate these RAIDs, and then to also find out different datasets, different scripts that have been used in different researchers, so other researchers can find out about this and easily apply for new experiments. And again, it would be getting to the results and finding out. Okay, so these are the potential collaboration that we have found for the moment at PID level, at EOSC Horizon Europe projects, at technical groups. We've seen a possible collaboration with FAIR for EOSC. Every time that I hear Tommy, I find out new things, so this is not all of it. I have found about PIDs for software, and so on and so forth. So the ones that I have identified is the one that sounds like similar, which is RAID, which is a PID for research projects and related activities. Thinking that could be interesting that if there are research analysis performed within these projects, could be also good or nice to have them linked. The PID meta resolver to make it easier and more accessible to resolve RAIDs. I have also found this Horizon Europe project, which is RDA Tiger, and I found that RDA has a PID interest group. I'm not just the most expert on this topic, but I've seen nice also to contrast the RAID novelty and disseminate our PID. Also, thanks to this EOSC symposium, I also got to know Tibor and Temis and the task force on PID policy and implementation. So happy to collaborate with you and the team regarding the alignment of our developments with the activities and to contrast the policy guidelines. And also to reuse and analyze collaboration of RAID with already mentioned ORCID for researchers, DataSite for PIDs, software heritage ID, and so on and so forth. So to make it as compatible, interoperable as possible. And the expected outcomes from these sessions, to have feedback on the concept, to have feedback from the community on the relevance, novelty of the PID. Any suggestion is welcome. And to start a discussion to connect ourselves with established PIDs and possible collaborations with other PIDs. So with that, we move to Q&A.
So thank you very much for the presenters. Also, thank you very much for keeping the time. I'm very thankful for it. I'm not so thankful for the branding you chose for your IDs, because having gray IDs and red IDs might challenge the community. Are there any immediate questions in the room? Do you have any questions? I have many, but I'm trying to be democratic enough to let the floor for your questions. Are there any online questions?
Yes,
Okay, so if there are no immediate questions, there is one.
Thank you. Just a question to Tommy. Great to see all of this work in the project. Really grateful. I was very interested about the kernel information work that you're doing. Obviously, this is also embedded within the handle system. So, of course, many of the arrays are not using this possibility to embed kernel information within the PIDs, within the DOIs. But I would like to hear a few more things about that, how you're approaching. What about how you're trying to standardize that? If you're looking into from a more domain-specific point of view, if you can summarize that, that would be amazing. Really grateful about your work you're doing on data type registry. This is amazing. This is very much needed also in the world of the fair distal objects architecture. So I would like also maybe offline to hear a few more things. But if you would like to share something more here, it would be also great.
Yeah. I realized that our project is an umbrella of like many different components, and I'm actually not able to discuss all the implementation details of all the components because I don't work so deeply in the component development. And while Tibor here is from GWDG, who are actually doing the kernel information profile development work and the meta-resolver development, it's his colleagues Sven Bingert and Hans Lienhop who have all the goody details on this. And your question on the kernel information profiles, yes, they come from the handle system. And that's what they are operating currently, and that has rich metadata. But then we have, for example, the URNs that have basically zero metadata. It just resolves, and that's it. So there is work that needs to be done on bridging the different levels of metadata that different identifier systems have inherently. And you can't, if something is already ISO standardized, you can't just go and add some stuff to it so easily. So I would unfortunately have to point you to the direction of Sven and Hans to get more information on that particular question. And the DTR is actually another goodie of the same institute. So that I can tell a bit more about, but we can also continue the discussion bilaterally.
Are there any other questions? Or as far as I see, the online question is coming in. Probably coming in later, so. Okay.
Thank you for the presentations. I was wondering about Ray ID. It's an identifier in itself, or is it the technology that you can apply on other identifiers? And also I was wondering, maybe a general question for other speakers as well, to which extent you collaborate with DOI, who's also experimenting, an organization that also, or PID that's broadening up and experimenting with a lot of technology, I think, as well. Yeah.
Okay, I can start maybe with RayID, which I would say that it's a proposal, and a new proposal for a new identifier, new persistent identifier, which currently it's built upon internal PIDs, I would say, but the idea is to go and use those that are already established.
Probably for the second question. So when new identifier types are coming in, they have different kind of requirements. Just to give you a concrete example, the PIDs, the instrument IDs, had the requirement to put quite different metadata into the PID record. This was at that time not possible to deal with data side DOIs or with other kind of DOIs. So they chose another PID provider. This is the Persistent Identifier Consortium, EPIC, where the handle records can be created basically freely and put any kind of metadata in it. Nevertheless, the technology, the PID technology, the PID service, the B2INT service is prepared to issue DOIs, to issue handle-based PIDs, and this is not the question. The question is, in this concrete case, in this concrete PID type, what to do with the metadata. And this is, I'm mentioning the identifier or the instrument identifiers because this is a kind of a use case or becoming a use case in the FAIRcore for EOSC project, where the team behind B2INT, the team behind the instrument identifiers try to model with those technologies, with the DTR, with the type registries, how the identifier record should look like. So the ideal workflow is someone creates a type registry entry which gets a PID. This describes how the PID record should look like. If a new version is coming, it gets a new PID, it gets defined again. And the technology, the service, the PID service is able to handle, able to understand this kind of schema description. It is generated automatically and understand how a PID record should look like. So you have a way to validate that kind of records and that kind of information. Depending on the requirements, the PID service provider is chosen. That would be my short answer. I'm looking in the back whether we are able to get the online question.
Alexandra has a question.
There was another question there, sorry. Hello, is this working? Perfect. I was asked to out loud this comment or question. I think this is, well, you can pick who will answer, but there's a person asking, PIDs for workflows will be handled as PIDs for software, question mark. PIDs for workflows will be handled as PIDs for software.
Not sure if that question is coming to me, but
yeah, you can pick it up.
But I understand that a workflow can be some kind of software-defined process. I mean, it's maybe up to a discussion, but I would say rather a more simple. I mean, I'm aware that there are some approaches to define workflows, in which I cannot recall the name right now, but I think the idea should go towards that.
Thank you.
Hi. Thanks for the nice talks. While you're talking, I'm thinking that there is an overlap between the PID group and the semantic interoperability group, and where do you cross the line between how much do you do on defining and identifying the metadata of its PID type, and how much the group of semantic interoperability is doing to actually make sure that they achieve interoperability.
So no one is volunteering to take the question. I take the question. I see some faces here in the room from the Fair Digital Object community. So I would answer in this direction. Depending, so the short answer is yes, there is definitely a huge overlap. And probably the border where the PID word ends and where the metadata word starts depends on the communities, depends on the scientific discipline, because some disciplines have acquired good understanding how metadata of objects could look like and have a good understanding how metadata of PID records could look like. There might be a difference between the two, how the PID record looks like and how the metadata for describing the research outcomes, the objects look like. Others are not so far. So probably they do not even differentiate between the two, what to put in the PID record and what to put in additional metadata records. And describing and understanding how that kind of metadata could look like is a community-based approach and kind of a governance issue. Who is deciding on what and who defines what? Are you happy with the answer or not?
We haven't discussed.
Yeah, okay, we will continue this in the coffee break. There was a question there and there.
Hello, I am Javier Albacete from the European Commission, and therefore I am a Eurocrat and not an expert, and I have a naive questions for all of you, for the speakers and for the experts in the room. So I have understood from the session that, well, there are gaps and there are many things that need to be done to have an harmonized PID framework that is fit for purpose, fit for EOSC. But I failed to see a little bit, I also saw and appreciate very much that you are working on very concrete solutions for many different steps along the chain. But I failed to see a little bit what is the big, so to say, strategic problem or the main blocking elements to actually get there that could inform policy decisions or investments. In other words, if you as a community working on these topics had to ask to your funder or your policymakers, authorities, whatever, identify clearly what is the blocking road, what kind of support do you need to get to these objectives, that would be very informative to us in concrete and I guess to everyone. So I failed to see a little bit that a long-term vision for a sustainable, integrated, harmonized PID ecosystem for EOSC. What is needed for you, the expert, as a community at large, to actually get the support that you need to get there? Does this has to be a mainly community-based process, or there is room for top-down intervention, so to say, to boost the process to make it faster? Thank you.
I have a dream. Yeah, someone?
I think that a lot of these things that we discuss make it apparent that there are gaps in the reproducibility of scientific results, whether it's source code or the kind of workflows that are done to produce research results. He has a dream that it actually would be maybe reproducible, what's written in the papers, and that's basically the criteria for accepting a paper, that it's described in such a way that the work can be reproduced. But the reality is that we can't always find the source code that was used to in the same environment in the same way, and when you run it, you don't get the same results. You can maybe create the workflow, or it's not documented in a precise enough manner that you can actually efficiently reproduce the results. So that actually hinders creating new science, because you're not efficiently able to reuse the scientific work done by previous scientists. And yeah, this basically works towards that aim, that you could create more efficiently, build on the previous work of others. You can actually take the analysis that someone else run, add something on top of it, and that would not take you 5 months, but instead 1 month. So I hate the word productivity, but that can actually improve the productivity of science, because you can more efficiently produce the results that others have done and build on top of that. And that kind of makes doing what you're interested in, actually analyzing, much more efficient, and you use less time in trying to kind of reproduce the building blocks. So that would be one answer.
I understand that. My question is, how do we get there as a community? A community involving everyone, policymakers, funders, average researcher, etc. So what would be your request? Should we as funders put a requirement in our grant model agreements that you have to do this, that, and that to every researcher that gets funded? Or should we set up other kind of incentives? What kind of interventions could get us collectively there to this? I understand the need for reusability and reproducibility. How do we get there? The big picture, that is what I'm asking. Just trying to, I don't have the answer, I'm just trying to foster the discussion. Thank you.
One step will be to, there was a slide in Tibor's presentation where we say that we should link the PIDs one to another. A first step could be to add guidelines, because they don't know how to do it, so that we can help them start using the persistent identifiers based on what you said on how we enforce what Tommy wants to do. So we actually can write guidelines for researchers, how to use the persistent identifiers, how they can use them in their publication, what to do, what is the best way to use them, because currently no one, it's a small proportional share of people that is doing that.
We are over time, so just a final comment on this. As far as I see from previous experience, I think neither a bottom-up approach nor a top-down approach would work here, but a kind of a combination of them. And happy to continue this discussion in the coffee break. There was a question.
From
Wim, yeah.
Yeah, thanks. We're out of time, but just a quick comment. I think we have to also note that there are some persistent identifiers that have a sort of a dual nature. If we define a persistent identifier for a person or a digital object, there's only one instance of that thing. But for things like instruments or workflows or protocols and methodologies, there is a persistent identifier for the instrument type. It's a Campbell scientific temperature sensor model, such and such. But there can be thousands of instances of that instrument that are calibrated differently and are used differently in practice. So for those kinds of things, we need two classes of persistent identifiers. The one is a type identifier, and the other one is an instance identifier.
Nothing to add, Wim. Thank you very much. If there are no burning other questions, then we would like to close the sessions. Thank you again for being here. And enjoy the coffee break.
Do you want to take a photo of four of us?
Yeah.